When dealing with algebra, since we have so many variables floating around, sometimes it can be kind of difficult to figure out how we can add things together. And to that end, well, I need to give some more vocabulary. First off, when we have a term, the constant, the numeric part of that term, the numerical factor of the term is generally called the coefficient. So if I had 5a, if that's a term I'm talking about, then 5 would be considered the coefficient here. A would be considered, well, the variable part. All right, 1.4 xyz squared. This has a coefficient of 1.4. Notice that 2 is not a coefficient here. 2 is an exponent. It's not a numerical factor. That 2 is not multiplied by this stuff. The only numerical factor here would be 1.4. If you had something like just xy, and you're asking, okay, well, what's the coefficient here? There is no numerical factor, right? Well, there's nothing explicitly written, but remember, whenever you're dealing with, if you want to write something in there without changing the value, when you're dealing with multiplication, you can always tack on a 1. So you could, whenever you see xy, you could call this 1xy. And so this one would have a coefficient of 1. So whenever there is not a coefficient explicitly written, you just say that it's a coefficient of 1. Similarly, if you have a negative, something like the opposite of a, the coefficient here, well, this is the same thing as negative 1 times a. So we would say the coefficient here would be negative 1. All right. Like terms. When we're dealing with two terms that have the same variable part, and the variable part has to match exactly, then we say that these are like terms. So 3x and 5x, the x's are the same on these. I don't care about the coefficients right now. All I'm saying is that they are like terms. And things have to match up exactly. So xy squared and xy squared are, those are like terms. But if we had something like xy and xy to the fourth, those would not be like terms. So because the variable parts do not match exactly. Remember that these exponents, these essentially are saying that we have this y repeated 4 different times in this one. We have x times y times y times y times y. This one just has x times y. And so this 4 is actually part of the variable part because it's saying how many times that y occurs. Similarly, 3x and 3x squared are not like terms for the exact same reason. All right. So the reason we're talking about this is because we want to be able to combine like terms. If we're adding together two terms that are like, we can rewrite it so that we only have one term. And how we do that is we take the coefficients, we take the coefficient of the first and add it to the coefficient of the second. So in this case, 2 plus 3 is 5, and then we keep that variable part the same. As far as why this works, well, you can think of it as having, this one is x plus x, this one right here is x plus x plus x. And you can see, if we just count them up, we actually have 5 x's, and that's exactly what this says. A common mistake that people tend to make on this one is instead of keeping that variable part the same, they want to do something like x squared or something like that. But remember, we're just counting up the number of x's here. There's 2 of them here, 3 of them there, there's a 5 of them total. This works for addition as well as subtraction. The coefficient on this one, now keep in mind when we're dealing with subtraction, the coefficient always includes the negative if there is one. So this, I'm really thinking of it in this way, plus a negative 3a squared x. So this negative 3 is the coefficient of the second number. 8 is the coefficient of the first number. So when I combine like terms here, 8 plus negative 3, or 8 minus 3 is 5, and we end up with 5a squared x rather.